Let's work on writing exponential functions based on the given information. So the general form for an exponential function is y equals c times a to the x. C is always the initial amount or the y-intercept, and a is either a growth factor or a decay factor. The most important thing to note is that it is a factor, not a percent that goes in the formula. So factor goes in the formula, f goes with f, not rates or percentages. So this first example, we have the initial value is 115. That's going to be our value for C. And there is a 12% growth rate. Only factors go in the formula, not these percents or rates. So I'm going to take that 12% and make it a decimal by dividing by 100. And I'm going to get 0.12. And since it is growth, this has to be a value that's bigger than 1 for a, or else it would not be growing. So it's going to be dividing by 100 and then adding 1 to get our growth factor for a. So our function is going to be 115 for our c, and our a, 12% growth means a 1.12 factor. If we do that same thing all over again, we have an initial value. There's our C, and a 4.9% growth. So 4.9%, we're going to divide that by 100 and get 0.049. Since it's growing, we add 1. So our factor is going to be 1.049, making our overall function y equals 58 times 1.049 to the x. On the other hand, we can look at some decay or decrease. So we would still look at C being the initial value, but a 30% decrease. If we want to make that into a factor to put it in the formula, we would still divide by 100, which would give us 0.3. But we don't want to add 1 because then that would be growth. We want a decrease. So we're losing 30%, which means we're losing 0.3 from 1. We're keeping 0.7. 1 minus 0.3 is 0.7. There's our decay factor. We're having less than 1. So we still make it a decimal, but we subtract it from 1. So our formula is going to be y equals 712, our initial. And then a 30% decay means we're keeping 70%, or 0.7 as our factor. Last one, we have another C, an initial value. 8% decrease or decay. We want to make that into a decimal by dividing by 100. We get 0.08, so we're losing 0.08 every time for an 8% decay. So 1 minus 0.08, we're keeping 0.92. So our equation is going to be y equals 120. And if we're having an 8% decay, we're going to keep 0.92 to the x. There is some practice writing some exponential functions in the form y equals c times a to the x when you're given a rate and trying to make it into a factor to put it into the formula.